So friends, continue with our exercise 7.10 NCERT questions. This is the second session of exercise 7.10. First part we have already done before. Okay, let's have a look at question number 6. So question number 6 says integration of dx over x plus 4 minus x square, and limit is from 0 to 2. Good. First we will try to convert it into perfect square. So we will do it. X square, so we write 4 minus x square and x take alone, right? So it is 4 minus, so it is x square minus, for x we will write 2 times x times half, right? And then plus 1 over 2 square. Basically we are converting to a perfect square. So we have done this changes, right? Basically I have subtracted minus 1 over 2 square. So I will add by 1 over 2 square, which is 1 over 4. So actually this becomes 4 minus 4 plus 1 over 4 will be x minus 1 over 2 whole square. So this is nothing but 17 over 4 minus x minus half whole square, right? And it is actually root 17 over 2 whole square minus x minus half whole square, right? So this thing becomes 0 to 2 dx over square root 17 over 2 whole square minus x minus half whole square, right guys? Now if you remember, this is a formula for, let me write down that formula for you. Dx over a square minus, and dx over a square minus x square is 1 over x. Good. So we'll use that. Here my a value is given and x value is x minus half. So I'm using that. So it is 1 over 2 a, and a is 1 over 2 times log of a plus x. So it is plus x minus half x, which is root 7 x. So while writing that, I will change the, because this was minus, right? Okay, simplifying further, this 2 and this 2 gets cancelled. So we get 1 over root 17, and it is log of, it becomes square root of 17 minus 1 plus 2x over square root plus 1 minus 2x, right guys? So, and then we'll apply the limits. Let's see that. So applying the limit from 0 to 2, we get, first we apply upper limit. So 1 over root 17 log of, when I apply upper limit, I get root 17 minus 1 plus 4, 17 plus 1 minus 4 by putting in for 2, right? And then I will put 0. So minus of log over root 17 plus 1, right? We did upper limit minus lower limit. Then we simplify more. We get 1 over root 17 and log of, this is over root 17 minus 3, and because this is minus, so this part would go in division, so actually it becomes root 17. Instead of division I am making reciprocal, root 17 minus 1, right? I have applied the log properties. Good guys, so that is 1 over root 17 log of, we'll just multiply them, right? So I get 3 root 17 plus root 17 plus 3 over 17 minus 4 root 17 plus 3. So that makes 1 over root 17 log of 20 plus 4 root 17. We will get log of, dividing all by 4. So we get 5 minus root, and that is my answer, guys. Good. Let's have a look at next question. Square plus 2x plus 5, and limit is from -1 to 1. So again we'll convert it into a perfect square. So we are doing it dx over x square plus 2x plus 1, and then we'll balance it with -1, and then plus 5 is there. That's how we do every time, right? Because this part has become perfect square. So I will rewrite it dx over x plus 1 whole square, and plus this part is 4, which is 2 square, and integration limit is from -1 to 1. So basically I'm sure you must be understanding the formula is dx over x square plus integration is 1 over a tan inverse x over a, right? I hope it is clear. So that makes, now we are integrating, so 1 over a, it is inverse x over a, so it is x plus 1 over 2. Then we'll put the limits. I'm keeping constant out, not a worry. So -1 to 1, tan inverse x plus 1, so it is 1 plus 1, which is 2 over 2, which is 1, minus tan inverse 0, right? So it is actually half. Geometry, I'm sure you must be knowing, is pi by 4. That's my final answer, right guys? Good. Let's try next question. Have a look at the question number 8. 2x square e to the power 2x dx, and limit is from 1 to 2. Just by looking at the question, I'm sure you must have realized that it is of this form: e to the power x fx plus f dash x, right? And the formula is e to the power x fx. But before we apply on that, guys, please understand this is not x, this is 2x here, right? So we'll convert this to, I will suppose 2x as u. Good. Okay. Why did we do that? Just to make it into the x form or u form. Okay. So once we did that, we will differentiate it. So it is 2 dx equal to d. So this entire question I will convert in terms of u. Okay. So for 1 over x, I will write, right? From what we suppose 1 over 2 is 1 over 2. And for x square, I will write u square over 4. Correct? And that is e to the power u. And for this is, for dx, we write du over 2. Good. So entire question I have converted to in terms of u. Guys, please understand these are the limit values for x. So when x is 1, so what is the u value? U value is, so this lower limit is 2. Okay. And when x is 2, my upper limit, so lower limit is 2 and upper limit is 4. Okay. Let's simplify 2 in denominator, right? So we'll rewrite it nicely. This 2, it is 1 over 2 out. Limit from 2 to 4. And it is 2 over u minus 2 over, and that is e to the power u and du. That if I suppose this as a function, this part is its derivative, right? 2 over u is the function and this is its derivative formula. So I'm writing that half of, for this entire integral I'm just writing x and over u from 2 to 4. Now apply the lower limit and upper limit, right? First we apply upper limit. So it is e to the power 4 times 2 over 4, which is 1 over 2. Minus, then we apply lower limit, e to the power. And yeah, that is our simplification. We are breaking the bracket, e to the power 4 over 4 minus my answer, right? Hope it is clear. Let's try next question. Next question is question number 9th. Integration of x minus x cube 3 all over x to the power 4 dx. And the limit is 1 over 3 to 1. First we have to understand why should we do that. From the numerator we cannot break, because the power is 1/3. It is like 2, 3, 4. No, it is 1/3. So breaking is also not possible. Denominator is x to the power 4, not helping too much. Okay. So let's try something. One thing. Why did we suppose as sine theta? You could have supposed as cos theta also. Let me tell you that. Okay. Now why did we do that? Guys, please understand. From here, when we take x common, we will get 1 minus. For that reason I supposed x as sine theta. So let me rewrite it for you. I am taking x, so x coming out would come with the power 1 over 3. So it is x to the power 1 over 3. It is 1 minus x square whole to the power 1 over 3. And this is x to the power 4 dx. And limit is 1/3 to. Okay. As I told you before, we are supposing x equal to sine theta. So we x differentiation is 1 dx equal to cos theta d theta, right? So this entire question I will write in terms of theta. See here, for x I am writing sine 1 over 3 to the power, and this is 1 minus sine square theta whole to the power 1 over 3, and for dx I am writing cos theta, and over limits we will manage later, don't worry right now. Okay, we will simplify it right now. This sign, we will bring them together. So it will become sine to the power 4 minus 1/3 theta, right? Right. For this part, guys, we will write theta. So it is cos to the power theta d theta, right? Okay. So that becomes integration of cos to the power over 3 theta over sine to the power 11 over 3 theta, right? Now, again a big problem. Numerator has cos with no sign or anything, and that also with a fraction power, and denominator is sine with some fraction power. So what to do? Can we do this? Have a look. I'm separating sine square theta separately, right? So 11 over 3 I separated 2. I hope you understand that. 11 over 3 minus 2 would be 5 over 3, correct? So it is nothing but sine 5 over 3 theta. Basically power 5 over 3 and power 2, when you add, you will again get 11 over 3, right? Now the benefit is that numerator has cos to the power 5 over 3 theta, and that is d theta. You do it now, the power 5, right? And that becomes 1 over sine square theta, which we will write as cosec square theta, right? Okay. Now we will do the supposition. Supposing cot theta as something, let's say a, right? So we get minus of cosec square theta d theta is equal to dA. So my this question becomes a to the power, and that is minus dA. Now here we will understand about limits now, guys, please understand. My limit for x was 1 over 3. So when x is 1 over 3, what will be my theta? My supposition value was sine theta equal to x, right? Inverse. So sine theta equal to, sine theta equal to 1 over 3. So theta is sine inverse 1 over 3, right? My theta is sine inverse 1 over 3. Okay. And when x was 1, theta equal to 1. So theta is pi over 2. So my upper limit for theta was pi over 2, right? Okay. Now when we have done this supposition, cot theta we have supposed as would be my limit, guys. I would make a triangle. Sine is defined as perpendicular over hypotenuse, right? So this would be 1 and this would be 3. So we can find this part, minus 1 square, which is square root of 8. So when sine theta is 1 over 3, at that moment cot theta is root 8 over 1, basic trigonometry. So my cot theta value is root 8, correct? If theta is pi over 2, when theta was pi over 2, now I am talking about the upper limit. So what is my cot pi over 2 value? Cot pi over 2 would be 0. So upper limit is 0. So this is my lower limit and that is my upper limit. So let me write that. Square root of 8 is lower limit and upper limit is 0. Good. Now this is the entire integration with negative sign. What we will do, we will manage the negative sign by changing the limits. I will make it from 0 to root 8. And this is a to the power 5 over 3 dA. And integrate a to the power 8 over 3 divided by 8 over 3. And then we'll apply the limits 0 to root 8. And upper limit is root 8 to the power 8 over 3 minus 0 to the power 8 over 3, which is anyway 0. Fine. So we get 3 over 8. Now guys, root 8 can be written as what? Root 8 can be written as 3 and whole to the power 1 over 2, correct? 8 over 3. Good. Fine. Now we know that all the powers will be multiplied, right? So this 3 and this 3 will be cancelled. So we get 2 to the power 8 over 2, which is 4. So it is 3 over 8 times 16, right? Which is 8 and 16 can cancel. We'll get 3 times 2, which is 6. So 6 is my final answer. Good. Let's try next question. 0 to x t sine t integration dt, right? And we have to find f dash x. Basically we have to differentiate it, correct? Now we have always learned that differentiation and integration are the reverse process of each other, right? I'm right now discussing the fundamental theorem, the first fundamental theorem, right? So this integration from 0 to x can simply be said as, this is the, when you differentiate both sides, right? When you differentiate both sides, you will simply get f dash x e sine x. In place of t and sine t, you will replace x. That is my answer. This is one way of doing, okay? Second way of understanding mathematically better, we'll understand fx is given to us integration from 0 to x t sine t, right, dt. So basically guys, we have to differentiate it, differentiate the integration, right? Okay, know the function, we don't need to integrate even. Let's suppose the integration is ft, correct? It must have some integration, and that integration would be in terms of ft, right? Okay. After we integrate, we apply the limits, right? So when we apply the limits, what do we get? In place of t, we replace x, correct? So we get fx minus f0. Okay, so that is my fx value. Okay, so this is my question right now. Now we have to differentiate this. So when we differentiate, what shall we get? We get this number is a constant, right? So integration of this would be 0. So basically we get capital F dash x. So my answer should be capital F dash x. Now what is capital F dash x? Ft was sine t dt, right? The integration of that. Taking fx will be x sine x. So yes, that is my result, x sine x. That's my answer, right? I hope it is clear. Or otherwise, the third method could be, right? So we will use it as a function I lay t e. So we have algebra and trigonometric. So an integration of sine t dt, I'm integrating it actually, right? Minus of differentiation of t sine t dt whole dt, right? So we get t sine t integration is minus cos t minus this differentiation is 1 and this is minus cos t, so it is plus cos t dt, right? So we get minus t cos t, and cos t integration is plus sine t. So we have this integration, right? And then we apply the limits. So we apply the limits 0 to x. So applying upper limit minus lower limit. So minus x cos x plus sine x. Anyway, so this is our integration, right? And this integration is to be differentiated. So we'll differentiate it now. So differentiation of minus x cos x plus sin x over dx, right? So I'm using the product rule on, and x times cos x differentiation is minus sin x and plus cos x times x differentiation is 1. So we are done with this product rule, plus cos x, right? When we break the bracket, we get x sin x plus cos x. So minus cos x plus cos x cancel sin x. So this is the third method, right? Among all three methods, the second method is more logical and more mathematical. If you can understand it, that is easy, right? I hope it is clear, guys. Thank you.